Hello, today we're going to take a look at how to solve rational equations. And what we need to do first with each of these is figure out our restricted values. With all of these rational equations, we're looking at where the denominator cannot equal 0, because if we try and divide by 0, it's going to be undefined. So we need to set each of our denominators equal to 0 to find the values that x cannot be. So for this first one, our only restricted value is 0. Then we need to find our least common denominator. With the least common denominator, we will multiply both sides of the equation by that. All of our denominators will factor away, and we will just be left with an equation that we could take to our Algebra 1 selves that they could solve. So our least common denominator in this case is just going to be 2x. A common denominator would be 2x squared, but then we'll end up needing to factor out an x somewhere. So let's just find our least common denominator, which is 2x. We don't need to count x twice. So we're going to multiply both sides of this equation by 2x. So our left side ends up as 2x. Then we have 3 times 2x divided by x minus x minus 3 times 2x divided by 2x. So then we factor out what we can. So the x is in this term. So we have 2x is equal to, well, this is going to be 6 minus. Then our 2x's factor out. And be careful with this. Your signs are important here. So we're subtracting the x minus 3. So when we distribute, it will be minus x plus 3. So, I was jumping ahead. So just watch what's happening with your signs. You're subtracting this whole numerator here. So combine some like terms, add x to both sides, divide by 3, and we get x equals 3. We double check. 3 is not 0, so we are fine. That is our solution. So here, n cannot equal 0. So our least common denominator, we look for what they have in common. Coefficient-wise, our least common denominator is 6 because 3 is a factor of 6. And then they all have n squared. So it's going to be 6n squared, and that is what we are multiplying both sides of this equation by. So we have 6n squared divided by 6n squared minus 6n squared multiplied by n plus 2 divided by 3n squared is equal to 6n squared divided by n squared. So we go through, we're going to factor some of these out. So this side, this term, be careful, it's going to factor to 1. Some people just look at this, and again, this is why I'm telling you to factor out. We're not crossing out or canceling or whatever, because if you just kind of cross those out and just move away, it just disappears. But it's 6n squared divided by 6n squared, which is 1. So then here, our n squareds factor out, and then 6 divided by 3 is 2. So this is minus 2 times the quantity n plus 2. Watch for your signs. Then on this side, our n squareds factor out, and we're just left with 6. Let's distribute our negative 2. Combine like terms. We'll add 3 to both sides. Divide by negative 2. So n is equal to negative 9 halves. Again, not 0, which is one of our restricted values. With this next one, x cannot equal 1/3, because if x was 1/3, then we'd be dividing by 0, and that would be a problem. We got 1/3 by setting 3x minus 1 equal to 0. And that's what our 0 of the denominator would be. So our least common denominator in this case is 3x minus 1. So we can multiply both sides of this equation by our least common denominator. So this term we end up with 3x minus 1. We're subtracting 5 times 3x minus 1 divided by 3x minus 1. If you're having trouble with these, I would highly recommend writing out this entire step with this. If you feel more comfortable with it and can look in your head at, oh, this is what's factored out, this is what remains, that's fine. Just watch your signs and make sure that terms don't disappear when they shouldn't. So we keep our 3x minus 1. We have these factor out, so we have minus 5 is equal to 1. That doesn't just disappear. 3x minus 1 divided by itself is 1. So then we will add 6 to both sides, divide by 3. X is 7/3, which is an acceptable value. Now, let's look at our least common denominator here. So first, n cannot equal, well, 0, because n is one of our denominators. But then for this denominator, it's helpful to factor it out first to help us find our least common denominator. So we factor out an n. So our least common denominator is n multiplied by n plus 4. So we don't need to include multiple n's because it's already included in that least common denominator, or it's already included over here. So we multiply both sides of the equation by that. All right, then let's start factoring out from here. So our n times n plus 4 factors out here. The n factors out here. N factors out here, and we can distribute the 3. All right, we'll subtract 12 from both sides. Subtract n from both sides. Divide both sides by 2, and get n to be equal to -2, which is not 0, or we need to set this equal to 0, so it also can't be -4. Two more we're going to take a look at. Here, x cannot equal, and our least common denominator, so let's factor out an x from this denominator. So we're left with x times x plus 1. Set that equal to 0. And so x cannot equal 0 or -1. Our least common denominator, they both share x as a factor, so we only need that once. So our least common denominator is x times x plus 1. So multiply both sides of this equation by our common denominator. Right. So here our x's factor out. We can distribute this. We have x squared plus x, and then include this plus x plus 1 equal to 1, because these factor out, and when both the entire numerator and entire denominator factor out, we are left with 1. It doesn't just disappear. So we'll subtract 1 from both sides, combine these like terms. Now, when we have any term that has a power greater than 1, then we're going to get this polynomial set equal to 0, and we can solve from there. So we're going to factor out an x. By the zero product property, set each of these each of these factors equal to 0. Then double check with our restrictions that we placed before. So x can't equal 0 or negative 1. So this x equals 0 is an extraneous solution. So our real solution is just x equals negative 2. So let's take a look at number 6 and see if this gives us any other extraneous solutions as well. So with some of these equations, some might end up with no solutions just because what you end up solving for could be extraneous, because if we substitute it into our original equation, we end up dividing by 0. So let's factor this first. So this is going to be n minus 5 multiplied by n plus 1. So n cannot equal 5 or negative 1. And our least common denominator ends up being this n minus 5 multiplied by n plus 1. So that's what we're going to multiply both sides of this equation by. All right, so now let's see what factors out. So here our n minus 5's factor out, and then we can multiply the 4 times the n plus 1. So we have 4n plus 4. Here, everything including an n factors out, so we are left with 5. And then we have to multiply these binomials. So we have n squared minus 4n minus 5. Distribute the negative 3. Now, since this is a second degree polynomial, to solve it we need to move everything over to one side so it's equal to 0. So let's try and move it to the left so that we have a positive leading coefficient. So we have 3n squared, and then we'll subtract 12n, so it will be minus 8n. Then we have 5 plus 15 is 20. We subtract 20 from both sides, and so we have minus 16. So that's going to be equal to 0. So what we can do with this, multiply the 3 and the 16, we get 48. Let's go list our factors of 48. So we got 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Now, since this sign is negative, we're looking for a pair whose difference is 8. So that's going to be 4 and 12. So when factoring by grouping, we're going to separate that middle term. Now, the negative 12n needs, or the 12n needs to be negative, and the 4n needs to be positive. Which order it goes in, if I had switched these, if it was 3n squared plus 4n minus 12n, it wouldn't matter. We'd end up with the same result. So we can factor by grouping. So this group, we can factor out of 3n. We're left with n minus 4. This group, we can factor out of 4, and we're left with n minus 4. So this factors to n minus 4 multiplied by 3n plus 4. By the zero product property, we set each equal to 0 and solve for n. So we check our two solutions, so 4 and negative 4/3, with what we determined at the beginning of the problem. Oh, our restrictions are just n can't be 5 or negative 1. So these are the two solutions for this equation. Thanks for watching.